Hey guys, I hope you're doing alright. I'm just gonna go through some of the questions from MathsWatch because I know I left you yesterday. Sorry I couldn't make it. But yeah, so let's go through the first couple of questions. I'll do first questions from every type of questions if that makes sense. So starting with plotting the straight line graphs. So as you notice, the topic is straight line graphs. Um, and we are hoping to get anything that roughly looks like this, right? So if you get any points somewhere here, it means you've probably made a mistake somewhere, because this is not the trend line, it's not the correlation line, but line of best fit. It has to go through all of the points, so that's very important. So has to go through all points. Okay, so what we do here is for each one of these x's here in the table, we are trying to substitute x into this equation. So we've got, I always suggest to start with 0 because it's the easiest way, because then you end up with 2 times 0 plus 3, which is equal to 3. So always, you could say, always, this is your value for 0. It's got its own name. I'll tell you about it in a moment. Okay, so let's take the next example. We've got 2 times 1, because the next x is 1, plus 3, which is 5. So you should notice the next one is 7. You should notice the trend. So we're going up by 2 each time. So this is going to be 9, and just before that we would have minus 1. So unfortunately, this line doesn't this sorry, this graph doesn't really show us the odd numbers, but we can guess they'll be in the middle, in between the lines. So for minus 1 we've got 1, for 0 we've got 3, 5, 7 and 9. And now you've got this tool there from on MathsWatch to join all of these lines together. As you can see, it depends how accurately you draw them, but you should hit all of the marks. So if you all of the crosses, if you have one of them somewhere here, that means you probably made a mistake when you were calculating what it is. So I said I'm going to come back to this, the value for 0. As you can see, the 3 is on the y line, so this and this at the same time is called an intercept. So this is quite useful to know. I'll explain you probably next week why is it useful to know. Okay, so this for now, you can pause it, you can copy it, try to have it there when you do the next question. And now if you look at question 3, so I skipped question 2 because it's quite similar to the previous one. I don't want to do everything for you. So you don't have a table, but it's not a problem to just draw it on a piece of paper or something like that, or just, yeah, it's better if you actually have it somewhere. And again, when you do that, do it for the values of x that you can see on the graph here. So -2, -1, 0, 1, 2, and 3. Okay, so the top one is x, the bottom one is y. I'll change the color. Again, as I said, start with 0 because it's the easiest, because look what happens. We've got 0 times 4, which is 0, -1, so -1. This is the intercept, right? So this is your intercept. For 1, we'll have 4 times 1 minus 1, which is 3. For 2, we will have 4 times 2 minus 1, which is 8 minus 1, 7. So again, you can probably see that it goes up by 4 each time, so the next one will be 11. And the previous one would have been minus 5, right? Because we kind of, if we are adding 4 each time, that means we had to add 4 here. So we had to add 4 from there, so again it should be minus 9. I can't really plot these points on this graph because I don't go as low as minus 9, but let's see what I can plot. I can definitely do the one for 0, which is here. I can't do the other one, but I can do the one for 1, which is here, and then for 2 is 7, and the next one I can't really do. But what I should be able to do is I should be able to draw the line that goes through all 3 of these points, right? So it should go as far as you possibly can. And so this is the part A. Part B, use the graph to estimate the value of x when y equals 1. So what you do really is y equals 1 here, right? This is the line called y equals 1. Now if I wanted to know what x is, I just need to drop a line here, and I can see it's x is equal to 0.5. So this is my estimation. So when they say use the graph, it's not for you to substitute it into here and calculate what it's going to be. It's for you to use the graph and actually see what it's going to be. Next question is the ABCD question, and I wanted to explain it to you because there are quite a few of these questions and all of them will require you to do roughly the same thing. So let's see what it means for each one of these lines. I'll explain to you what these lines mean, because when we've got x equals 4, so let's say 2, 4, x equals 4 will be a straight line that goes through x at 4 like that. Okay, so this is the line x equals 4. You should know this. So if it's x equals constant, if it's x equals a number, it will be a straight vertical line. No, is that okay? And then if y equals constant, so the other y equals constant. So question D again. Let's say this is 4. So it will be a horizontal line. Just correcting. Okay, didn't look right. Right, so this is y equals 4. Okay, so y equals constant, straight, horizontal line. I'll use a different color to show you what is y equals x equals y. X equals y is the line that goes equally through x and y. So whatever x is, y is exactly the same. So it goes like that. So you can see here for 2, y equals 2. For 4, y equals 4. For 6, y equals 6, and so on. So this is x equals y. And the last one, we'll have to do a bit of shifting here. I'll use a different color as well. So look, if we did, because we want to have y equals something, right? So I'll have to take away x here, in order to have y equals something. So it's y equals minus x, right? So question B is y equals minus x. So whatever y is, it is minus x, or whatever x is, it is minus y. So what we can assume is going to happen is going to look exactly the same like this, but it's going to go the other way around. So like this, right? So now I can see if y equals 4, x equals minus 4, right? So this is what it means. So y equals 4, x equals minus 4. Okay, so choose the equation of the line that is parallel to the x-axis. This is the x-axis. The line that is parallel to the x-axis is D. All right, and you have to, so I explained to you the typical questions that you can see here. The next couple of questions, A, B, C, D, will look like this, and you just have to come back to this slide and see what it means when x equals constant, when y equals constant, and so on. The next example is question 7. I wanted to do question 7, as this is a different type of question again. The reason why it's got a different type of question, it's got x and y on the same side. So we could go through that and just try to substitute numbers instead of x and work out what y is, or we could find the equation for y. It's up to you. I don't want to confuse anyone, so I'm just going to keep substituting the numbers for x. So as I said, I'd start with x equals 0. So it'll be 0 plus y equals 6. So something plus 0 equals 6. That must be 6. The next one is 1 plus y equals 6. So of course y must be equal to 5, right? Because 1 plus 5 equals 6. Then we've got 2 plus y equals 6. So y must be equal to 4. 3 plus y equals 6, so y must be equal to 3. And you can see that we go down by 1 each time, so that's going to be 7, that's going to be 8. And we can plot that now. So for minus 2 we've got 8, then we've got 7, 6, 5, 4 and 3. We take a straight line and we try to match with all of the points. Now on the grid, draw the graph. So we've done that. So that's the end of the question. We've done both of the things that we needed to do. And next question is question 8. I wanted to do it again just because we've got a 2 here now. So let's have a look how we can do it. Again, you start with x equals 0. So we've got 0 plus 2y equals 7. So I can forget about that. 2y equals 7, y must be equal to 3.5, right? Because if double something equals 7, a single of that thing will be 3.5. For the next one, we've got 1 plus 2y equals 7. So we need to take away 1 on both sides. So that'll be 2y equals 6, right? We take away 1. So y equals 3. For the next one, we've got 2 plus 2y equals 7, so we take away 2 on both sides, and we end up with 2y equals 5, so y equals 2.5. For the next one, we'll have 3 plus 2y equals 7, so I need to take away 3, 2y equals 4, so y equals 2. Okay, so you can probably see what's going on here. We're going down by a half each time. So that will have to be 4, right? Because if we're going down by 0.5 each time, we must have gone down from 4 to 3.5. And then before that it would have been 4.5. And now the second part of the question says, plot the graph, so we're going to try and do it. 4.5 here, 4. So you can see it all creates a straight line again. Next question. Question 9. So this is slightly different. We don't have a table here. You only need two points really to plot a graph. You don't need all of them, you just need two, because a line, if we have 2 points anywhere on the surface, we can always join them with a line. So this is the reason why they only ask you what are the points for P and Q when P is 0 something, Q is something 0. What it means is the first one is the x coordinate, the second one is y, and the same here. So they ask you basically, what is the value for y when x equals 0? So we're going to find that out now. All we do is 4 times 0, which is 0, plus 2y equals 8. Right? So I just substituted for the point P. I substituted 0 for x, and this is going to be 0. 2y equals 8, so y must be equal to 4. And now for point Q, I'll do it maybe down here. For Q, we've got 4x plus 2 times 0, which is 0, equals 8. So 4x equals 8, x equals 2. Okay, so we've got these 2 points, and now we just need to plot them for x equals 0, y equals 4, for x equals 2, y equals 0. So just here. For these 2 points, we can draw a line. We can go as far as we want. As you can see, we don't need to. Yeah, so we don't need to just stop at between these 2 points. And they say use the points to plot the coordinates. That's fine, we've done that. And the last bit, in the last sub-question, they tell you draw the line x plus y for x for values from x minus 2 to 3. So they actually want us to drag it as far as possible, right? So yeah, that's all. Let's have a look at the next question. This one. So here we're talking about gradient. Gradient is basically the how steep the function is. Okay, so we've got, let's say, y equals 2x plus 1. I told you already that this is called an intercept. Now, the number that stands next to x is what we call a gradient, so it tells us how steep the function is. The bigger the gradient is, the steeper it'll be. It also tells you by how much it goes up each time. So you know when we were going through these tables, the gradient here would have been would have been 0.5, actually minus 0.5, because we go down by a half each time. So this equation will look like y equals minus 0.5x plus the intercept, which is 3.5. Okay, so what I'm going to do, I'm going to go through all of these questions here now, and I'll show you from the, especially that we already know what it is, I'll show you from the intercept and the gradient, how we can build a function equation. So y equals something x plus something else, right? So the something else will be an intercept, which is 3 in this case. And our gradient, look how we go up. So we go up by 2 each time. So we get 2x plus 3. And look, it's exactly the same as here. Let's look for the next question. So here we're looking at the table. The intercept, it crosses at -1, so the intercept is going to be -1, but we want to know how many x. So we add 4 each time. So the gradient will be 4x minus 1. And look at the question. It is actually 4x minus 1. So I hope you get the idea here. Here we need to do slightly different thing. We don't know the values, but we can quickly draw a table x and y for just a few values. So I would start with 0, 1, 2. So for x equals 0, which is here, y is 1. But I'm talking about line A. Y is 1. So this is our intercept, please remember. For x equal 1, y is 3. For x equal 2, y is 5. So this means we go up by 2 each time. And our line for A will be 2x plus 1. 1 is the intercept, so this goes here. Right, for B, I'll change the color. For B, again, I'll just draw a quick table for a few values, so 0, 1, 2. For 0, we've got 5, so this is the intercept. For 1, we've got 4. For 2, we've got 3. So our gradient is -1 because we go down by 1 each time. So the line will have the format of -x or -1x plus 5. Right, so the intercept is 5, the gradient is -1, so we could either have this or -1x plus 5. I'm not sure if MathsWatch will accept that because they are quite specific about, you shouldn't, I said that a few times I think, you shouldn't really do -1x, it's just -x. Okay, so this is how you do the gradients and finding the equations of the lines. Oh, actually, they tell you, so I've done too much. They tell you only to find the gradient of the function, which is this. So the answer to A will be 2, and to B will be -1. So sorry, I did too much, but you'll know for the next lesson what to expect. Okay, let's have a look at the last question, which is slightly different. We've got sequences here, but it works the same way. So what they say is the nth term of a sequence is 3n plus 2. Work out the first 3 terms of the sequence. So first 3 terms, we are looking for answers when values of n are 1, 2, 3, right? We're looking for the first 3 terms. So if you substitute n with 1, you get 3 times 1 plus 2, which is 5. Then for 2, you get 3 times 2 plus 2, which is 7. 3 times 3, 9, plus 2, which is 11. No, I did it wrong. Sorry. That should have been 8. Oh. Right, 3 times 2, which is 6, plus 2, 8. Okay, now it makes more sense. 5, 8, 11. Now, work out the 10th value of the sequence. So, instead of n, I'm just going to substitute 10. So it's 30 plus 2, 32. That's all. Thank you very much. Let me know if you've got any other questions about this work, and I hope you'll be able to finish it by the next week. Take care, everyone.